Hey everyone, today I want to go over multiple different ways of collection traversal in Java. There's many different ways of going about this depending on the type of collection, and they all have merit in different situations. In Java, some of the most common collections we use are derivatives of either arrays, lists, sets, and maps. There are of course lots of specific versions of these and others as well, but for simplicity's sake, I will focus on arrays, lists, and sets. For demonstration purposes, I will be declaring and initializing a variable of each type, containing strings. I've gone ahead and predefined an array filled with some example string elements. Then I'll go ahead and do the same for a list of strings using the static of method on the list class to create a list containing the same elements as the array. Then I'll do the same for a set. Great. So now that we've declared each of our variables, feel free to skip to the part of the video which interests you using the timestamps in the description. So yeah, one of the first ways we learn to iterate in Java is iterating by index, which generally only works for collections which can be indexed by a number, such as an array or list. The format for this is as follows: using the for keyword, then within parentheses, declaring a variable, in our case, just one integer, I, that is initially set to 0, as that is the first index of an array. It is standard to name this integer I, which stands for index. You can define multiple variables using a comma as such, but it is common to stick with one variable declaration. These statements will execute only once before the for loop runs. Then, after your variable declarations, we add a semicolon and place a condition. This condition is checked to be true before executing each iteration. You can make this as complicated as desired, but for simple iteration purposes, we tend to create conditions such as I is less than list.size or I is less than array.length, with however you get the length of your index collection being what I should be less than. This is because in Java, these collections are indexed starting at 0. So if we tried accessing the item at the length or greater, we'd get some sort of out of bounds exception. So we use this condition to stop right before that, after the last index. Then we place another semicolon and specify expressions to execute after each iteration. In our case, incrementing I, so we can actually iterate over our collection. Now, we specify the functionality of the for loop within the scope of a set of squiggly brackets. Since my condition is based off of the array, we can, for example, print out the element at index I in the array, specifying the index to help illustrate its traversal. If we go ahead and run this, we can see how the array was traversed. For each element, the index, then the value being printed out on its own line. For a list, it would look pretty similar. Instead of array.length, we would use list.size. And instead of using the square brackets, we would use list.getI. Otherwise, it would be the same. If we run it, we should see this be printed out both times. To help illustrate how this all worked, the equivalent using a while loop would look as follows. First, declaring your iterating variable, in our case, int I equals 0. Then, checking the condition in the while loop parentheses. Just like last time, I is less than list.size or I is less than array.length. Then, within the squiggly brackets, executing our code just like before, and finally, incrementing the index variable at the end. If I go ahead and comment out the previous loops, we can see that this logic ends up working the same. Remember though, for sets, you cannot use either of these methods, as sets are inherently unordered and do not have indexes. Therefore, they do not have a .get method, nor can you use the square bracket indexing. This next method will work for sets as well as any collection which implements the iterable interface. That is a for each loop, which some call an enhanced for loop. It starts the same way as the earlier method with the for keyword and parentheses. Then within the parentheses, you declare a variable to store the element you're going to be iterating over, which in this case has the type string. You also give it a variable name for which each element will be referenced through during each iteration. I'll give it the name s, since our elements are strings. You can also use var here instead of the type in Java versions 11 or greater, as the type can be inferred, just like this. Then you can type a colon and proceed to put the reference to the collection, whether that is an array, list, set, or any other iterable object. Keep in mind though, if we use a set, such as I'm doing now, there's no guaranteed order, since as I said, a set inherently lacks order. I'll add a print statement, and as a whole, this loop can be read as, for every string in the set called set, store it in the variable s, and print it out on its own line. This is a pretty common construct, as it is rather useful to quickly loop over collections, but if you need the index for some reason, the previous fori construct may be better suited for your needs. Another common method is using an iterator. Anything that implements the iterable interface can return an iterator, including all collections, as collection itself implements iterable. From our examples, this is list and set. First, we declare a variable to store iterator. An iterator also accepts a generic parameter just like list and set. In this case, we'll specify that we are iterating over strings. We give it a name, whatever you'd like, but I've seen it often called iter. Then we set it equal to our collection, such as our list, dot iterator. There are also list iterators, as you may have seen, and other derivatives, um, depending on the collection, which expose more functionality. But those can be different depending on the collection, and the generic iterator will fit most of the situations you come across. Now that we have our iterator, it is common to use it through a while loop, but that's not always the case. What that looks like, though, is again using the while keyword. Then, within the parentheses, using the condition to check if the iterator has a next item, using the self-explanatory dot has next method, such as I have just written. Then, within the squiggly brackets, we can access the current item using our iterator dot next. This moves the iterator forward though, so if you need to access the element multiple times, make sure to store it in a variable, such as this. And we could proceed to print it out or whatever you need to do. That's great. Now, one final technique which I tend to use quite often, which was introduced with Java 8, is using the functional for each collection method. This allows for easily readable condensed code, but can be harder to grasp at first, so it's okay if not everything here makes complete sense. So the general idea is as follows. You take your collection, such as list, which has a method for each. It accepts a consumer, which is essentially a function which accepts one parameter and doesn't return anything. It like consumes that parameter and doesn't give you anything back, right? We could pass in a function from elsewhere, or we could specify an inline one, which is what we'll do here. This can be done in a few ways, including specifying a whole anonymous consumer class, such as this, but this is unnecessarily verbose and complicated, and we can simply use a lambda, which IntelliJ is even trying to tell us. What that looks like is essentially like this. First, you specify a variable name to store each element, just like our for each loop earlier. But we don't need to explicitly specify the type this time. We'll call it s just like we did before. Then you add an arrow, which is composed of a dash plus a greater than sign. After that, we can specify one statement which can use this variable, such as system.out.println s. If I go ahead and comment out our existing code, we can make sure this works, and we can see that it goes ahead and prints out each item on its own line. That's great. But what if we need to specify multiple lines, or what if we need to do more than one thing? Well, we can go ahead then and add squiggly brackets to specify multiple statements, such as this. And you can specify as many as you need. and where S will refer to each element. In both cases, what happens is the method handles the iteration and passes the S into this lambda expression of ours. In the case of having a method, which is already a consumer that accepts one parameter and doesn't return anything, such as system.out.println does, we can instead use a method reference, where we essentially pass in a reference to that consumer method using syntax, which essentially looks like this, where we refer to the method that we want to pass into the for each method. Java understands this as pass each element in the collection or in this list directly into this method's only parameter. If we run this, we can see the logic will still be the same. I won't go into all the details of how these functional approaches work in this video, but they are super cool, super quick to write, and pretty easy to read. So I hope you give them a shot as they are becoming more and more commonly used. So yeah, these are some different ways of traversing over collections in Java. They can all be useful depending on your situation, and of course these methods are not the only ways of accomplishing things, and every situation has its own solution. If you have any questions or need any clarification, feel free to reach out to me in the comments or on my Discord, and I'll do my best to help you. For reference, you can find links to relevant Javadocs in the description. Thanks for watching. I hope to see you in the next Java video. Bye.